Good morning, everybody. Turn to page 454. We're doing lesson 108 today. It's some more on square roots. Just recognize that if we have something like the square root of 2 and we square it, we get 2. So if we have the square root of x and we square that, we get x. If I have something like the square root of x minus 2 and I square that, I get, that's right, x minus 2. So over on page 455, 108.1 says the square root of x minus 2 plus 3 is equal to 0. In order to solve this, the first thing that you want to do is isolate that radical. So we need to get this radical all by itself, which means we need to subtract 3 from both sides. So we'll have the square root of x minus 2 is equal to negative 3. All right, now, just like we did up here, we can square both sides of the equation, not just one, but square both sides. And when we do that, like this just becomes x minus 2. Negative 3 squared becomes 9. And then you add 2 to both sides. So that gives you x equals 11. Okay, well, ordinarily with most other problems we'd be finished at this point. The problem is that we squared both sides of the equation here to get rid of that radical. And when you do that, sometimes solutions occur that aren't valid solutions. They're called spurious roots. And they only occur because we squared both sides of the equation. So what we have to do is we have to check it. And you must show this on your paper or you won't get credit. So make sure that you show this next step. So I go back to the original and I plug in what we got for x, which was 11, minus 2, and that added to 3 has to be equal to 0. If it's not, then that's not a valid solution. So 11 minus 2 is 9, so we have the square root of 9 plus 3 has to be equal to 0 in order for this to be a solution. So the square root of 9 is 3. 3 plus 3 is not equal to 0, is it? Okay, that tells me that, if I can get it to change, that tells me that x equals 11 is not a valid solution, so I'm going to mark it out. And I'm going to write no solution. Make sure you always show your check. If you don't, you'll get burned. Okay? I won't give full credit if you don't show the check. All right, next. The square root, this is 108.2. The square root of x minus 2 minus 6 equals 0. So what do we need to do first? Get the radical by itself, which means add 6 to both sides. So we have square root of x minus 2 again, they like that radical, equals 0 plus 6 is 6. And then to get rid of the radical, we square both sides of the equation. And that gives us x minus 2 is equal to 36. Add 2 to both sides to solve it. So x equals 38. Now are we done? Only if you don't want full credit for the problem. If you want full credit, you've got to take this 38 and put it right back in here. So the square root of 38 minus 2 minus 6 has to be equal to 0, otherwise it's not a valid solution. 38 minus 2 is 36, and the square root of 36 is 6, and 6 minus 6 is 0, therefore, x equals 38 is a valid solution. Okay? Next, at the bottom of page 455, 108.3 says the square root of x squared plus 9 minus 5 is equal to 0. Alright, so what do we need to get rid of? Get rid of the negative 5 by adding it to both sides. So the square root of x squared plus 9 is equal to 5. And then we square both sides of the equation to get rid of the radical. So this squared comes out as x squared plus 9. It's exactly what's under the radical that comes out when you square it. That's equal to 25. And then subtract 9 from both sides, so x squared would be equal to 16. Well, what's the square root of 16? What did you say it was? It's plus and minus 4. So we have to check both of those. So going back up top, I'm going to check the positive one. That would be 4 squared plus 9 minus 5 equals 0. And over here, negative 4 squared plus 9 minus 5 has to be equal to 0. Well, that's 16 plus 9. And this is also 16 plus 9. So that's the square root of 25. And over here, the same thing. So what's the square root of 25? 5. And 5 minus 5 equals 0. So guess what? They both work. There are two solutions to that one. That's okay. It's all right to get two solutions. Okay, next. The square root of x minus 1 minus 3 plus x equals 0. Now remember, the whole deal is we've got to get rid of the square root, which means we have to isolate it. So we've got to get rid of both of these. So we have to add 3 and subtract x. Add 3 and subtract x. Remember, whatever we do to one side, we have to do to the other. So we have square root of x minus 1 equals 3 minus x. Now what do? We square both sides of the equation. But you've got to remember, guys, this is a binomial. This is not under a radical. So this is 3 minus x times 3 minus x. It's not just, it doesn't come out as 3 minus x. It's not under a square root. This one comes out as x minus 1 because it was under a radical. So when we multiply this using FOIL, we're going to get x minus 1 equals 9 minus 3x plus x squared. Alright, so because I have an x squared in here, I know I have to set everything equal to 0. Okay, so that means I'm going to subtract x and add 1, subtract x and add 1. So I'll have 0 equals 10. That would be minus 4x minus 3x is minus 7x plus x squared. And it's not super easy to see what that is to factor, so I'm going to rewrite it in the other order. And yes, that does factor into x minus 5 and x minus 2. And then we set each one of those equal to 0. So x minus 5 equals 0 and x minus 2 equals 0. X equals 5. X equals 2. Okay, are we done? No, we're not done because we squared both sides of the equation. So I have to check x equals 5 and I have to check x equals 2. Both of these I have to check to see if they're going to work. Okay, so sorry about that. Alright, so we have x equals 5 and x equals 2. And the original equation was x minus 1 minus 3 plus x equals 0. So we check both of these. So square root of 5 minus 1 minus 3 plus 5 has to be equal to 0. And the square root of 2 minus 1 minus 3 plus 2 has to be equal to 0. Alright, so that's the square root of 4. And that's the square root of 1. And you guys laugh, but people always, they leave it as the square root of 1. The 1000th root of 1 is 1. Any root of 1 is 1. Don't leave it under a square root. The square root of 4 is 2. 2 minus 3 plus 5 equals 0. And 1 minus 3 plus 2 equals 0. Well, that's negative 1 plus 5. Negative 1 plus 5 is 4 is not equal to 0, so that is not a solution. And over here, 1 plus 2 is 3 minus 3. That gives us 0 equals 0. So this one is a solution. Okay? Alright, one more. And this is a square root equal to another square root. Pretty simple. How do we do it? We square both sides. So we have 2x minus 3 equals x plus 2. Subtract x, add 3, so we get x equals 5. Are we done? No, but almost. Plug in 5 to the original equation. And please don't forget to check this. I hate to count off half because people don't check. So 2 times 5 minus 3 had better be equal to the square root of 5 plus 2. So that's the square root of 10 minus 7, and the square root of 7. Excuse me, I was thinking ahead of myself. That's 10 minus 3. So it's the square root of 7 is equal to the square root of 7. So it checks. And we can go back here and circle this answer.